Hello, welcome guys. Welcome to this channel. After a long time, I'm preparing a new series of videos because really I was not I was not well actually, so I was not able to prepare those videos on daily basis. So that's why there was no video for a long time. So basically, we have started courses for AWS Big Data, AWS Machine Learning, AWS Deep Learning, and AWS DevOps as well as for AWS Solution Architect. The same applies to your Azure DevOps, Azure ML, and Azure Architect level, and the same applies to the GCP also. So we have fleets of services, but uh, what I'm planning to do here is I'm planning to help you guys for your DevOps interviews, DevOps cheat sheets, and the small, the small training courses that will give you the enough idea, enough information about that. And along with that, some real world talk also, real world scenario, because we are, working in the real world. We face a lot of issues. So I'm just trying to gather all those things and we'll share with you in this training. So let's start with that. Today's topic is Elastic Container Service from Amazon. So what is that? First of all, why we need to learn this Amazon Elastic Container Service. We have two options. One is ECS or EKS. Amazon is promoting their um, for their client the ECS also and EKS also. So both of them they are not totally different, but some differences are there. So the first thing that we will go to learn is what are what is the container service? Why we need to container, for example, all monolithic applications breaking into the small pieces that those pieces will work as a microservices and microservices will be consumed through API. So there's a lot of talk out there about the um, about microservices. So let's start the Elastic Container Service. So the core objective here is that microservices, the benefit that microservices based architecture and application has over a monolithic application. So why companies are moving from monolithic to the microservices based architecture. So difference between the containers and the virtual machines. Maybe in this training, something you might have already known, so you can skip that part. But it's an introduction that I'm giving. We have this course. If you are looking for this course, then please contact me or our team basically. That we are we will be happy to assist you. So difference between the container and virtual machines, how to create your own containers and run them in the ECS and deploy them either serverlessly or through EC2 instance. These are the small objectives. It's not very very big video, very large, very long, boring video. It's going to be very short. And as a part of a next release, a next part of that video, I'll be sharing the cheat sheet for your EKS and ECS. So you no need to go through all the 3 or 4 hour training. You just go through the cheat sheet and you'll be good. But most important thing is that during this training, we discuss lots of real world scenarios, real world problems, the scenarios basically. What are the pain points? What are the things we stuck during our deployment? So that will give you the enough idea about that. So you don't need to be a part of all the change, but sometimes you better from your network you can learn those things. So it's something you can take advantage of our experience or my experience basically. So this is the course objective. Let's get started. The problem of monolithic application. What is the problem of monolithic applications? So monolithic applications are tightly coupled. So if you see this one, this is a typical diagram where you can see that these are the tightly coupled thing. Means it's very difficult to work on a particular user interface level or business logic level or data access level. So that is the issue. That is the problem that we are trying to um, solve it in the in container system. So monolithic architecture is something like this. You are building. all the applications layer with the front end, back end, database, middleware, everything in one complete black box, which is really difficult to break those things. So if something happens on one part, then entire application will go down. That is the problem with the monolithic application, monolithic architecture. Assuming that there is a web application or a website where user can create the account, user can post the updates, user can post the comments, and there is a live chat option also there. So imagine that there are four parts of that big application. Now, if everything in comes under the one big monolithic application, then if any issue happens in the current creating account side, then it will affect the all other parts, and then everything we need to reboot it. So single monolithic application, that's as I said, it is tightly coupled, like hardly like welding kind of thing. They cannot live without each other, and that is something we don't want because in this complex application, if you see around you, more and more companies are adopting generative AI based thing. So if you see this AI based models and those things, you will notice one thing: these are all decoupled applications. There is no total dependency on anything on anything. Means, for example, there are four or six parts of an application. All six parts can live without each other. I mean, they are coupled, but it's a loosely coupled. The term that we use is a loosely coupled. Why loosely coupled? Because if anything happens on particular creating account, it should not affect the post update, comments, and live chat. It's very easy to troubleshoot. That's the first thing. That very easy to troubleshoot, very easy to deploy, and future ready. Means because future ready means we don't want to create big monolithic applications again with a Java team will working on round the clock. And end of the day, if something happens, then we need to bring down everything and shut it down and restart everything. So restart mania. Earlier Windows system we used to if blue screen is there, then there is a reboot button is there. But nowadays, if you see, the reboot is not required for everything. The reason is this all loosely coupled. So application components are loosely coupled. That is the reason we don't need a reboot. So all the services they can work together, but also they are not totally dependent or tightly coupled with each other. So that loosely coupled is the key here. So imagine that these things, for example, creating account, if creating account has having issue, then entire application needs to be bring down. So that is the issue with the monolithic one. And microservices architecture means let's if we create separate microservices. Microservices means components of a new microservices based architecture. Microservices means a small component where it has their own database, it has their own, separately, I mean, like container based. So inside the container, they have everything, whatever they need. So I will create a container for this one. I will create the container for this one. Similarly, I have created the four pods or containers basically. I'm not saying that in one container you can create you can put everything in there, but the group of containers also we can use the pod, and a group of containers also can be managed as a one container or as a kind of a microservices. So these microservices, when you see these microservices, they contains this component, the live chat. Maybe this is the live chat. This is the past updates. This is the create account. So now these things are loosely coupled, not tightly coupled, right? So that is something we want during our microservices deployment. So ultimately, um, these things can be processed inside the container. So intention here is that it should be container based microservices. Container means Docker container. We are not considering any other container service. This is the Docker service that we are saying. So now I can move this one. These things are maybe the API calls, you can say. So in order to consume these services, microservices, you can use the API calls. So I have this container which is having code, and then code can be, framework, binaries, configuration. So that container has everything that you need in order to deploy any application on the container base. So Amazon ECS will take care of that container part. So Amazon ECS will provide you tons of EC2 instances. On those EC2 instances, you will have Docker container, and those Docker containers can be managed as a cluster. So ECS will manage your container service. You manage your all the containers. That's a raw term that you use. So ECS basically will manage your all your container. Maybe container one, container two, container three, and that's maybe that this all three containers may be on one EC2 instance, or these containers may be on different EC2 instances. That there's something ECS will take care of that. And good thing about the ECS is, the container services, once you develop the microservices, that can be run on any of the platform, Microsoft, Windows, Mac, whatever platform you're looking, that will, the application can run on those platforms. So virtual machines, we know that, virtual machines are very big, heavy, because we have a guest OS along with the CPU, memory, those overhead is there. And on top of that, we have a hypervisor on top of hypervisor, we have all these things. So it's very heavy basically. And heavy things, it's very difficult to move. That's a nature that if you have very heavy things, it's very difficult to move. And in this world, if you are not, your applications and technology is not thin, lean, and movable, then it will be problematic. Similarly, if you see here, this host OS, on top of that we have Docker, and on top of that we have this containerization. So on top of Docker, we don't have any OS. If you notice, there is no OS here. OS is below the Docker. That is why it is very lightweight. So if I move everything, this application by refactoring that application, and move all the components of that application as a microservices in ECS, then it will help me to manage it. I can scale it down. So scaling means I have a 4 instances where I have, Docker container installed. So ECS will allow me, ECS will give me the opportunity, the flexibility that I can do the, scaling also. So this is, there's a normal phenomena who are, familiar with the AWS, they can understand that. It's very easy to scale in and scale out things. Scale out means more, scale in means, reducing that one. How do we use containers within AWS? So there are two ways. One is your own cluster, and the second one is serverless. So fully managed container orchestration service, developing, managing, scaling containers workload, use Docker containers, industry standard. The second thing is ECS cluster. The first thing, in the part of that, the ECS cluster. I mean, you will create the cluster, or ECS will create the cluster in which multiple EC2 instances will be there, and then, um, on top of that, we have Docker, and ECS will manage all your, containers in the EC2 instances. That's the that's the first one. Then there is a Fargate also there. Means you, if you want to manage all your EC2 instances, or down the line when you have more than 3,000, 5,000 EC2 instances, you feel that okay, there's let's go for a serverless. Serverless means Amazon will take care of those services. You don't need to worry about the server. You just create the cluster, and whatever inside that, you know, that background, how many servers, what are the servers required, that will take care by that. Those headache will taken care by Amazon. So you just need to, worry about the Docker engine, Docker. That's a serverless option. Nowadays, the serverless options are high in demand because of some other reason also. What is that reason? The carbon footprints. More and more CPU and more EC2 instance you use, um, the more carbon footprints on the planet. So serverless is high in demand. So AWS Fargate will take care of that server part, and you don't need to worry about creating any EC2 instance. You just need to deploy your applications on the Fargate cluster. So this is the journey from server to serverless. Earlier, server deploy in a month, sometime earlier days, 15 year back. Then deployment in minutes. Now the container services are containers are deployed in second, and serverless been deployment in milliseconds. You don't need to worry about anything, whether to deploy, how to create, and those things. So those things will be taken care by the vendor. Where to keep your code basically. Code means your images. So ECR is a container registry that will over there you can keep your all the images. The images you create from Docker file, Docker build, and the images. So those images you can store in the ECR. ECR either you can access publicly or you can host them highly available and scalable way. So it depends on where do you want to from where you want to access the your images, because images are very important, because images is something based on that you will create the containers. So ECR lifecycle is there. So you create lifecycle policy, test rules, save the rule. All the rules are evaluated and image are marked. Then this is a typical lifecycle policy of the ECR. Now important thing in the ECS is a task definition. Remember in EKS and in Kubernetes we have a manifest file. So similar to that manifest file, we have a task definition. So which Docker image to use, what resources to allocate, network specification, other all details will be there in the task definition. So task definition file is something your manifest file where you want to deploy your applications on ECS. Though all the details where you mention, that file is called task definition file. And it contains configuration memory limits, configuration port mapping, set the name and image for the container. So all those details will be there in the task definition file. So in task definition file, when you see the ECS, you can have a two option. One is servered or one is a serverless. Forget is the best option to if you want to manage. I mean, if you want to, ACS to be if ECS will manage your servers. So on top of that, there is a load balancer concept. Now we cannot compare point by point with the Kubernetes one, because Kubernetes works bit differently. But most of the features are same. You can map those features. So here there is an application load balancer. Any request comes to this application load balancer, then load balancer will decide which microservices, the group of microservices group is available. I mean, available means the which is group is healthy. So same thing, the application load balancer, we have other videos for application load balancers also, where you can go and see what is a load balancer, what is application load balancer. So this is the architecture of microservices architecture where you are breaking. Not you can see, don't use the word break, it's a refactoring. The word typical word is a refactoring of your application. We'll show you one .NET or Java application, how do we refactor that application, and then you can create the microservices for that. So similarly here I have created four microservices here. So one is create account, post account, and these are the API calls, API thing from where you can access the microservices. So the next video I will prepare for you guys is to show you how we do the refactoring. So in case in an interview somebody asks you that, okay, uh, tell me about your project. So always give some idea about or prepare yourself for some one sample refactoring. So guys, for interview point of view, four things are very much important. What are the four things? The first thing is the refactoring experience. How do you refactor the application from monolithic to microservices? That is the first thing. Now, what is the second thing? Second thing here, you should be able to write any Docker file, Docker to container. Now, the third thing is, writing any manifest file, means any Kubernetes manifest file. And the fourth thing is writing a simple Python script. So those four pillars, when those four things, if you know, then your chances to crack the DevOps interview is very high. And we will prepare you for those things during our training. But guys, make sure that you are keep on learning. So don't stop the learning. For any issues, if you want to learn something new, if you like the video, if you want to contact me, if you want to join any course, we have thousands of promotions are going on, so it will not cost you more. But remember, guys, spend on your technology, spend on your skills. The most important thing you spend decision you have taken in your life is to spend some money on your skills. So it's an investment. This is not the spending. Okay, guys. Thanks. It was nice talking to you guys. Let me know if you need any help or you want to join the course or just watch my new videos and happy learning. Thank you, guys.